Good afternoon, everyone. We meet again in the engineering geology course. Today, we will be discussing on sedimentary rocks. Sedimentary rocks. All rocks exposed at the surface of the earth are subject to weathering. Rocks break into fragments that are transported by winds, ice, and water and can be deposited to form a sediment. Small fragments are transported further than large fragments. During weathering, many of the original minerals break down to produce clay minerals. An important mineral that does not break down is quartz. As they become buried, loose sediment like sand, silt, clay become consolidated and form compact rocks, sedimentary rocks. The process that transforms sediments into rocks is called lithification. Could be formed from decomposition of plants and animals and other materials that were also formed from decomposition process, physically and chemically. Sedimentary rocks are generally divided into first, clastics or detrital, second, chemical and biochemical organic rocks. The texture of sedimentary rocks can be classified into first, clastic texture, second, non-clastic texture. The structure of sedimentary rocks can be classified into internal structure, external structure. Based on the time when the rock were formed, the structures of sedimentary rock can be classified into primary structure, secondary structure. Since most sedimentary rocks are derived by a process of weathering, transportation, deposition, and diagenesis, the texture we find in sedimentary and sediment rocks are dependent on processes that occur during each stage. Clastic sediments and sedimentary rocks are classified on the basis of predominant grain size of class in the rock. In sediments or sedimentary rocks, the porosity depends on grain size, the shapes of the grains, the degree of sorting, and the degree of cementation. Well-rounded coarse grain sediments usually have higher porosity than fine-grained sediments because the grains don't fit together well. Angular grain of fine-grained sediment can be compacted to fit together better, and thus porosity is reduced. Mud rocks, because of fine grain size, usually have very low porosities. Poorly sorted sediments usually have lower porosity because the fine-grained fragments tend to fill in the open space. This is the example of sedimentary rocks according to its texture. Conglomerate, shale, sandstone. This is clastic rock. Limestone. This term is applied to the large and petrographically diverse group of sedimentary rocks in which the carbonate fraction exceeds the non-carbonate. If more than 50% of sand-sized quartz, silt, or clay is present, the rock is calcareous sandstones or calcareous mudstones rather than limestones. Limestones and dolostone are commonly the most indurated members within the younger sedimentary sequences. They may yield good aggregate provided they have a dense crystalline or cemented fabric and are not weakened by the existence of cavities or high porosity. The strength of limestone vary from soft and hard depending on the type of limestones. Its shear strength depends on the texture. Porous limestones have low shear strength, while the compacted one has a high shear strength. Limestone's particles are usually cemented together with clay, and hence their bonding strength will decrease when it is exposed to water. Usually contain joints or empty pores. The empty pores might be filled with fine-grained soil. Contains thin layer of sandstone, and this layer can be permeable and is weaker than the limestone. Sandstone. Sandstone is light-filled accumulation of sand grain, which are acknowledged by most authorities to range in size 0.06 to 2 mm in diameter. These grains, which are predominantly quartz, were produced by weathering and attrition of pre-existing rocks and were sorted, abraded, and transported by moving ice, air, water from sources outside the basin of deposition, where they become consolidated commonly by cementation into the coherent rock. Coarse grain sandstone with angular or subangular particles are termed gravestones, and admixture to other materials in addition to quartz gives rise to range or arenaceous rocks. For example, a feldspathic sandstone is termed arkose, and the prints of lithic or rock fragments and clay minerals produces the gravic. Sedimentary rock sandstones. The strength of sandstones depends on the degree of bonding and the type of bonding material. They have bearing capacity that is proportional to its strength. The joints are usually distant. Shale. The strength of shale vary. The soft one can be easily quarried by tools and without using dynamites, while the hard ones can only be quarried by using dynamites. Shales have closely layered structures and are easily to be separated along its plane. When they are wet, their shear strength is very low. Shales often become soft or clay silt after being submerged into water for a few days. The process of deposition usually imparts variation of layering, bed forms, or other structure that give clues to environment in which deposition occurs. Such things as water depth, current velocity, and current direction can be sometimes be determined from sedimentary structure. Thus, it is important to recognize forest sedimentary structures so that we can interpret the clues that they offer to this condition. Also, because sedimentary rock can be deformed by folding and faulting long after the deposition process has ended, it is important to be able to determine which was up in the rock when it was originally deposited, especially if one is going to use the rock to determine the sequence of events that occurred or interpret the geological history of an area. Features that tell us which way was up are often referred to as top and bottom indicator. One of the most obvious features of sedimentary rocks and sediment is the layer structure which they exhibit. The layers are evident because of difference of mineralogy, cut size, degree of sorting or color, or the different layer. In rock, these are differences may be made more prominent by the differences in resistance to weathering or color changes brought out by weathering. Lamination is a small-scale sequence of fine layer that occurs in sedimentary rock. Graded bedding. As a current velocity decreases, the larger or more dense particles are deposited first, followed by small particles. This results in bedding showing a decrease a grain size from the bottom of the bed to the top of the bed. This gives us a method for determining tops and bottoms of beds, since reverse grading will not be expected unless deposition occurs under unusual circumstances. Note that reverse graded bedding cannot occur as current velocity increases, because each layer will simply be removed as a current achieves a velocity high enough to carry sediment of particular size. Cross bedding consists of sets of beds that are inclined relative to one another. The beds are inclined in the direction that the wind or water was moving at the time of deposition. Boundaries between sets of cross beds usually represent an erosional surface. Cross bedding is very common in beach deposits, sand dunes, and river deposit sediments. Ripple marks. Ripple marks are characteristic of shallow water deposition. They are caused by waves or wind piling up the sediment into long ridges. Asymmetrical ripple marks can give an indication of current direction. Symmetrical ripple marks differs from when the water moves back and forth. Symmetrical ripple marks occur in environment where there is a steady back or forth movement of the water. Such ripple marks can still be used as top and bottom indicators. Mud cracks. Mud cracks result from the drying out of wet sediment at the surface of the earth. The cracks form due to shrinkage of sediment as it dries. In cross section, the mud cracks tend to curl up, thus becoming a good top or bottom indicator. The presence of mud cracks indicates that the sediment was exposed at the surface shortly after deposition, since drying of the sediment would not occur beneath a body of water. Stromatolites. Stromatolites are layered mounds, columns, and sheet-like sedimentary rock. They were originally formed by the growth of layer upon layer of cyanobacteria, a single-celled photosynthetic microbe that lives today in a wide range of environments ranging from the shallow shelf to lakes, river, and even soil. Flute casts or soil marks. Flutes are elongated depressions that form off the bottom of the body water as a current erodes. The flutes may form a mold into which new sediment is deposited. Trace of soil. Among the three major types of rock, fossils are most commonly found in sedimentary rock. Unlike most igneous and metamorphic rocks, sedimentary rocks form at temperatures and pressure that do not destroy fossil remnants. Often these fossils may only be visible under magnification. Well, that is all for this session. Until we meet again in the next session, thank you.